All right. So this is going to be the pre-lab video for experiment number 15, the enthalpy changes in the chemical reaction. Now, this one's a little bit different than what's been in your lab manual because we are going to make some adjustments. So we are looking for, in your lab, we're supposed to be using sulfuric acid with sodium hydroxide. Now, this is a base, and this was an acid. And so they're going through something called a neutralization reaction, where we make water and the salt. And if we balance that, we should have 2 sulfates. And that means that we make 2 waters and we need 2 sodium hydroxides. And so this was what our chemical reaction was supposed to be. Now we're going to modify this a little bit because instead of doing our sodium hydroxide, we're going to use something different. We're going to use potassium hydroxide, KOH. And instead of being sulfuric acid, we're going to use HCl. Now they're both still going to go through a neutralization. But it's going to look a little bit different. And so what we're trying to find out for this reaction is we would like to know that this delta H, how many kilojoules of heat does it release or require per mole? And then specifically, we're going to look for per mole of KOH that's neutralized or dissolved. Now, we're going to do this by using some calorimetry. So that means that we're going to have a container, right, our calorimeter. And inside that container, we're going to mix different amounts of our liquid. So it might be our water, it could be our HCl and our KOH. And when we mix them, we're going to measure the temperature change. Of our solution. So we're going to be using the equation Q. We're going to look at that mass and that heat capacity and that delta T to figure out how much heat is being released or consumed by that process. So remember that if our water or our solution, if that delta T is positive, then that means it gained heat, which means that our reaction had to lose heat. Now, if the delta T is negative, that means that our solution lost heat, which means that the delta H of our reaction must have gained heat. And so that's what we're going to look at between those two. So our big change is we're going to do an online simulation where we're going to use KOH and HCl instead of this H2SO4 and this NaOH. The second part that's changed is in part 1. Instead of using this concentrated sulfuric acid and a more dilute NaOH, we're going to use our potassium hydroxide, and it's going to be a solid. So that means that our KOH has to first dissociate, which means that it needs to move over into its aqueous form, which means it's really going from KOHS to a positive ion and a negative anion. And then this is going to react with our HCl. To produce that water and that aqueous solution. We can make that one a little bit better. Okay. So that's what our reaction is going to be for part 1. We're gonna look at this in two different steps for part 2 and then part 3. One of them is we're just gonna look at, well, how much energy did it take for us to split that hydroxide or that potassium hydroxide and dissolve it into its ions. So if we want to look at this, we're looking at this delta H for a reaction in part 1. We're looking at this delta H for a reaction in part 2. And then we're going to use a third one where we're using our HCl and our KOH, that's aqueous, to make that water, and that KCl, that's aqueous. So this KOH that's really here is really it in ions already. So that's the same as us writing it as K plus. So when we're looking at these reactions, we can kind of see that these two reactions put together looks a lot like this one reaction. We can see that our KOH as a solid plus the HCl as an aqueous plus our so that's just reactions part 2 and part 3 put together. We can remove the stuff that's spectators, so those two go away. And our reaction looks a lot like what we have up here in part 1. We have KOH as a solid plus HCl aqueous going to our water as a liquid plus KCl aqueous. So we're going to compare the delta H for the reaction in step 1 versus delta H of the reaction in 2 and delta H of the reaction 3. So we're going to compare those two things together. Now, as we go through this, we're going to have an online simulation that's going to find our values for this. So I'll show you how you guys collect your data in the next video, the one entitled Lab Data. We'll also walk through what's going to change about it and how you guys do those calculations. Now, at the end of the day, once we find these delta H of those reactions, we'll know the absolute energies that we absorbed or released for that specific experiment trial that we did. Now, what's important is we're going to take our data for those delta H's, and we're going to divide it by the moles of our KOH, because what we want at the end is the delta H to neutralize the KOH, and that's going to be in kilojoules per mole. And then we'll be able to compare it against standard values, right? And so we don't want it to rely on specifically how much we put in. So at the very end, when you guys get to the bottom in part G, we're going to take the delta H from each of our reactions, divide it by our moles, so that way we can get the delta H of our neutralizations in kilojoules per mole. Okay, very good.